Great. So my name is Nat Zappia, and I'm the director of the Institute for Sustainability at CSUN. Welcome to our final webinar of our month-long weekly webinar, looking at issues around sustainability and victory gardening and thinking about the future, especially in this unprecedented, extraordinary moment in history, where we have to rethink everything, rethink the way we do business, from the most mundane tasks to the biggest tasks, biggest challenges. And it's with great pleasure that I'm going to introduce a group of students and faculty who are thinking about this in a very innovative and very aspirational and interesting way, particularly as we think about our campus and returning back to our campus. So let me just tell you really quick. So the Institute, before we do that. So a little bit context about this presentation now. So the Institute for Sustainability works with many different departments, other centers on campus, and one of the departments we're working with is Liberal Studies, and Liberal Studies houses our sustainability minor, and so we work with many of the students within the minor on different kinds of projects, internships, helping them facilitate for reports and research. And so the minor has a capstone course, the 401, which is when the minors, as a precondition or as a way to finish, to get the minor, they have to do a capstone project together. So we've got 4 students, and Professor Lisa Chaudhary is the faculty member who teaches this course. I think hopefully she's here, or she'll be here any minute. And for this project, we've worked on actually a few of these projects, and one of them I'm very proud to introduce, as I said today. I've been working with Lisa and Professor Spiros Lazarus, who is an engineer working in the Department of Engineering as well. He's been teaching at CSUN for many years, and we've been working on different kinds of sustainability projects, and this is one of them. And also another, not a faculty member, but a working farmer who was part of the consultation process is Scott Murray as well. And so we've worked together with this group, who you're going to meet right now, Sal, Sean, Tyler, and Anthony, all come from different disciplines. And really, I think, represents the best of what sustainability is about, where you have different interests, different perspectives coming together to create an action-oriented project. And with that, I'm going to turn it over to them and let them speak for themselves and talk about their project. But as they're presenting, if you do have questions or comments, just write them in the chat room, and I'll be able to view them and ask for you on your behalf, or if you have any comments that you think that you want them to address, I'm happy to do that at the end, but also in between here and there, in between the slides. If there's something that I think that they need to address right away, I'll have them do that as well. So with that, I'll turn it over to our group. But thank you guys for presenting today.
Thank you, Professor. So hello, everyone, and again, thank you for attending today's webinar. So we're going to present the Living Lung, which is our collaboration project with the Institute for Sustainability. And my name is Anthony, and let's get this started. So our project. Our overarching sustainability solution is active carbon sequestration, which is the process of using new vegetation in order to capture the carbon dioxide in the air and integrate it into the plant itself, where it will be stored for a long time, as long as the plant's alive or mixed into the soil. And this is going to be achieved through the utilization of drought-tolerant native plants that can easily survive our local climate and live on for many years to come. And on the note of drought tolerance, one of the important components of our proposal includes water management. And our principal strategy for using permeable surfaces is to replace the impermeable walkways, so things like concrete or asphalt, which don't allow water to seep down into the ground itself. And we can use other breathable and porous materials that do allow water to gradually sink in rather than just running off onto the street and into storm drains where it might collect pollutants, it'll just run off into the ocean, whatever may happen. So the next logical step would to be to keep it in the soil itself. So through the use of cover cropping and shading the soil with tall plants that have canopies, is to use, again, these native plants that spread on the ground or have these wide canopies that also give soil stability so that they don't erode away with wind or rainfall and contain that moisture for longer periods of time. And so far, all of our sustainability solutions have the characteristics of building up soil. Since these ground cover plants, these tall trees, they naturally will shed their organic material that then breaks down and becomes part of the soil itself. So not only are we making it more attractive, but we're making the environment stronger. But one of the core of the problem is greenhouse gases. So we talk about carbon sequestration, but it's important to notice that it's not the full picture, where we have methane that comes from agriculture or unsustainable waste management like landfills, and then nitrous oxide from manufacturing or vehicle emissions has a large impact. But these things all require us to change how society lives, and we need to work towards reducing these future emissions. But this is a preventative measure, which is still important, but we need to integrate more. We need to do more. So for the existing emissions, we are looking for active carbon sequestration as a means of restoring our environment, not only preventing future emissions. Sorry, let's see. All right. So this concept also work with CSUN on its own carbon goals, which is carbon neutral by 2040. So our breathing lung is planning on hitting a lot of these big points of excessive CO2 emissions, the water consumption, impermeable ground, and groundwater depletion. So not only are we going to try to fix the local environment, but we're going to try restoring it and improving it. And fortunately, we do live in and contribute into a socio-political environment that actively supports climate science and sustainability efforts. California is at the forefront in the US with efforts like the California Air Resource Board, which has worked to fix our infamous air quality issues that have actually gone better over the decades. Furthermore, our CSU system has its own emission and sustainability goals, which means that we learn and live on a campus that actively seeks to teach us and create students who are agents of change in our own professions in the future, while improving the institution's own footprint. And as for our collaborators, change is not easy without a strong leading force that can organize and promote what the next required steps are. The Institute has worked with the campus, local professionals, and students to develop and implement many campus improvements that bring forth change and opportunity. And we have listed here just a few of them. So this is why our proposal comes with a high feasibility, since our partners and ideas have shown prior success and do so in a way that can be easily adopted and work in tandem to achieve our active carbon sequestration goals. And to explain further into how we figured out where to implement these projects, I'm going to hand it off to Sean.
Thank you, Anthony. To look for potential sites, we decided to spread throughout campus. The best way for us to divide over 350 acres was to first establish criteria. The most important to us was that the site would be where there's a lot of foot traffic. This project, being that it would be the first of hopefully many projects throughout campus, we wanted a lot of exposure to the CSUN community to show the Institute's efforts towards its goal of being carbon neutral by 2040. Also, we looked for sites that needed some enhancement or beautification. where we would come in and perform enhancements, but with sustainability solutions. To make it easier for us to divide the campus among 4 people, we use the grids established for the tree atlas. The grid shown on the slide covers the main campus. Plummer Street is the northernmost boundary, Matador Road to the east, Nordhoff Street to the south, and Darby Avenue to the west. The highlighted grids are where we found potential sites. One of the sites actually is in both B2 and A2, and I will show that in a couple of slides. Now first, grid D4. For the grids that were analyzed, the total area of the grid and the areas of the blue and green zones were determined. For the blue zones, the area of the walkways was also calculated, as some of these walkways could be converted to permeable pavement and enable capture of groundwater. In D4, a quarter of the area is green zone, and the walkways equal to almost 10% of the entire grid. And C3, the potential site in C3 is the courtyard in Sequoia Hall. The green zone is about half of the total grid area, and the walkways take up 10% of the entire grid. And this is what I had mentioned earlier. Grid B2 is within the yellow box. Potential areas are the sloped lawn south of Sierra Hall and the open lawn adjacent to Manzanita Hall. The lawn next to Manzanita Hall actually goes into grid A2. But now let's first take a look at grid B2 only, which includes a portion of the site by Manzanita Hall. In grid B2, the green zone is just over a quarter of the entire grid, and the walkways is 9% of the total grid area. And the potential site that is in grid A2, the lawn next to Manzanita Hall, now only the area of the potential site that is in grid A2 was determined, not the entire grid. 25% of the site, the area highlighted in pink, is impermeable pavement. Now, after looking at all the potential sites, we chose to begin analyzing the site in D4, which we call Site A. This site was chosen because it is right outside the Matadome and Sports Complex. And with the new parking structure right next to Site A, the foot traffic on the site would include not only faculty, staff, and students of CSUN, but also campus visitors for campus events and activities, and perhaps prospect matadors. Now let's look at, take a closer look of Site A. This is looking towards the new parking structure straight ahead. Matadome is to the right and the sports complex to the left. And this is down to the bottom of the slope. Now, as you can see, this is a neglected space that could use some TLC. So why not do it with sustainability solutions, right? The existing landscape in Site A includes mainly grass and weeds. And this is looking into Site A from the opposite side. There is one sweet gum tree amongst the grass and weeds. And this is the strip of green zone to the east of the building. And next is Tyler, who will go into our proposal for Site A.
All right, so here's our proposed plan for the site. Things might look like a little crooked, but that's because we traced this with over a satellite photo in Photoshop, since none of us ever drafted landscaping plans before. So this is in itself was a challenge for us. We proposed 2 main changes for the site. One is that we replaced the vegetation that was there. It's largely currently covered in deer grass, so we want to keep that since that's a native plant. This site has a lot of northern exposure. So because of that, there's a lot of shade in the southern half of the site. So in that southern half, we're proposing installing shade tolerant plants such as penstemon, honeysuckle, and coffeeberry. while the northern half would see more drought-tolerant plants such as sagebrush, fuchsia, and manzanita. The other change we propose is the installation of permeable pavement. This will allow rain and runoff to percolate into the ground. And next, I'm going to talk about the impact that these features would have. All right. First one, there is native plants. There will be a few benefits to using native plants, especially they are especially adapted to the local climate. They do better than most non-native plants in handling shifts in climate as climate change exacerbates, as well as dealing with localized weather events such as heat waves or flooding events. After roots take to transplanting, they'll need minimal maintenance and they won't be invasive, so they'll save water usage. And again, since they are adapted to local conditions and local predators, there's a reduced need for pesticides and fertilizers. And fourthly, native plants strengthen biodiversity, such as local pollinators, birds, lizards, etc. All right. In addition to the above ground benefits, changing the vegetative regime of the site will also have benefits below ground, namely increasing the site's soil organic content. Soils can sequester more carbon than what can be stored in the plant's biomass. This is especially true in Southern California, where we don't have major forests. We're mostly chaparral with relatively small annuals and perennials. So sequestering carbon instead in the soil is especially effective. We want a more densely vegetated plant, because as these plants die back and go dormant in the summer and fall, all that biomass will go into the top layer of the soil as compost. And as the plant remains break down, they get incorporated into the soil. Furthermore, the roots and shoots of the plants we propose will help feed bacteria, fungi, worms, and other soil organisms. These soil organisms create what's known as a soil aggregate. And what a soil aggregate is they are clumps of soil glued together by organic material. These aggregates keep carbon in the soil immobilized in the local area. In addition to changing the vegetative regime of the site, we also propose installing permeable pavement. Instead of normal impermeable pavement that we're all used to, it is a useful change because they would allow storm and rainwater to infiltrate into the soil. And through this infiltration, there will be consequently reduced runoff into storm drains. And lastly, since this pavement allows for infiltration, the ground below it can serve as additional rooting space for healthier vegetation. Right. So how much carbon would get sequestered if these changes are enacted? Originally, we intended on performing lab work ourselves. In coordination with the campus's water quality lab, we would have performed loss on ignition analysis, which would have told us the percentage of carbon content within the soil. However, due to the campus shutdown, we lost access to our labs and equipment. So what we did instead is, after some research, we found a carbon sequestration case study that was done in Marin County here in California, which has a similar climate to us, and more importantly, the same soil type. So with that study as our proxy, we estimated that the above ground carbon sequester would be about 100 kilograms per year. In the soil, it'd be about 2,600 kilograms of carbon per year, to a total of 2,700 kilograms of carbon per year. That's the equivalent of about 963 gallons of gas per year, or 6,000 pounds of CO2 per year. It's worth noting that the sequestration wouldn't be indefinite. And if it's like the study in Marin County, then it'll reach a steady state after about 30 years. So over the course of 30 years, we would expect about 83,000 kilograms of carbon stored. And next to talk about costs and wrap it up for us is Saul.
Thanks, Adler. Now I will be introducing the potential costs for this project. Here are some estimated prices. We're looking at obtaining around 20 sacks of cattle manure for somewhere around $26, and this was through the advisement of Scott Murray, who is a sustainable agriculture consultant. With 40 years of organic production experience in the US and Mexico, Scott has provided expert consultation to us in this project. Since we are introducing increase soil carbon storage, the use of screen mulch would also be necessary, and we're hoping that this can be campus source. Now, when we are looking at potential costs for permeable concrete, we are looking somewhere from $54,000 to $68,000 for this project. Now, depending on the native plant species that we choose to use for this project, it also depends on the amount that will be expended. And these prices do not reflect the actual cost for the entire project, but we are estimating it to $100,000. This including the removal of the concrete and the introduction to permeable concrete solutions. In summary, our proposed landscape changes for active carbon sequestration have several cost-saving and comfort benefits. It holds the potential for so much more that will build up our local environment, and it will renovate our relationship with biodiversity and the native species. You will notice through our project that it offers reduced maintenance, water use, and reduced air and ground temperatures while having many other benefits. This includes attracting native animals, resilience during extreme weather, while also increasing the health of the soil, reducing water runoff, and replenishing the groundwater table. This is an opportunity for our educational institutions to build deeper bonds and have a unified effort that will amplify the benefits to relatively small changes. This is an active and evolving concept that invites other students and departments to pitch in their creativity and expertise to extend the proposed concept and to farther reaching impacts beyond our original scope. And the overall goal is to promote sustainability within our community. And through these efforts, we can build collaborations with other schools and ultimately create a domino effect in which we inspire other people and other schools to follow in the same path to address the climate change problem of greenhouse gas emissions. Now, the following slides are our references. Thank you all very much. If you have any questions, please leave them in the chat and we'll be happy to answer them.
Excellent work. Do you guys want to show that little supplementary slideshow about planting? Did you want to do that, or before we ask some questions, or?
Yeah, give me about a minute or two and I'll pull it up.
Sure. Okay. So while you're doing that, maybe I'll kick it off. That was, you know, you've heard from me already. I think it's such a impressive collaboration, and I'm just curious to hear. And again, if feel free, folks who are listening, if you have any questions to jump in as Anthony's pulling this up. But how did you? I guess I'm curious about your process. Maybe you guys could, each one of you, just really quickly tell everybody your, you know, what your major is or your background. I mean, all of you are graduating, all of you are seniors now, and just how you, we know how you got together in this class, right? Because you took this capstone class, but maybe how your background, because they're all so distinct in terms of your academic interests, how that shaped this collaboration.
I guess I can go first on that.
Sure.
A big part of what this project can represent for me is how a lot of the climate change issues are such a large scale thing that an individual might feel like it's such a small impact that one can make. But the thing is, as we kind of talked about, it offers up collaboration and uniting efforts where, yeah, us changing that one site, in the grand scheme of things, it might be a drop in the bucket, but it's not just us alone. So it's bringing up the aspect of community and individual efforts that are then copied by more individuals, making it easier for the next person to do more.
Yeah.
I can go next. Adding to what Anthony said, the reason why I've been so inspired to work on this project is, like, as a finance major, I never really looked into sustainability, but my twin brother actually introduced me to it, and I said, like, what is my degree gonna, well, like, what's the value of my degree gonna be if we're in a planet that can no longer progress, you know? And so I always heard the terms the saying, think globally, act locally. And so for me, this project was an introduction to finally feeling a part of a change, and introducing and also helping me learn about sustainability and how I can help, and what areas need help in today's world.
And as for me, as a transfer student, I went straight into just the upper core classes. And so I've never really ventured outside of Jacaranda Hall. And I wanted to work on a project that was on campus to learn more about campus. And this project just sounded to me like it would have such a great impact that's a lasting impact. And I wanted to contribute, kind of like a gift to give back to CSUN.
Yeah, that's great.
The question was about how like our majors and background contributed to like the methodology.
Yeah, and maybe how you all work together, but we could do a follow-up on that one too.
Yeah, like so I'm a geophysics major, so reading stuff like the soil profiles, I had like a bit of an edge over the layperson in that regard. So I liked researching the science stuff, but there's a lot of stuff that entailed in this project that I didn't know about, and there was skills I didn't know. So I found that just trying stuff out was surprisingly, I don't know, effective.
Yeah.
That was my takeaway.
Yeah. Excellent. Well, I have some, we've gotten a bunch of questions here as we've been talking. So maybe Anthony, maybe we'll answer a few of these, and if you want to, we could show that slide after if we have time.
Yeah, I have it pulled up, so that's ready as soon as we get
cool.
to some of these questions. Okay,
cool. So, well, first, got a lot of folks saying great proposal, very cool. So a couple of nitty-gritty questions and then larger questions that I don't think you have an answer for, but maybe you have some thoughts about it. And that's, of course, I'll start with that one first. Well, I'll pose it first, and then maybe we can answer the nitty-gritty first. So a couple people asked about cost. So Sal, you mentioned costs, and you guys have thought a lot about that. But the question is, how will we pay for this? That's out of your purview, right? And then will this raise the price of tuition, for instance? Someone asked. So you don't have an answer for that, obviously, but what would you? We've talked about costs, and we've talked about that your project could potentially have cost savings, right?
Right.
So maybe you guys could. You mentioned that in the presentation, but maybe it's worth just talking about that, how you see costs, and then I'll ask these nitty-gritty questions.
Okay. So in terms of like saving money, we were thinking ideas such as like having workshops, just like the Sustainability Institute offers workshops where we might be able to get to this space and work on it ourselves and weed out like what we need to weed out, or just help fix the soil. So there's definitely a lot of volunteer opportunities here in terms of what we can do to save money. But in terms of funding, I mean, we were hoping to have this proposal here and get all these metrics and all this data and kind of I mean, from my understanding, just have like some sort of funding from the school, and I don't think it would a factor into raising the price into tuition, but it's something that we're looking into, at least getting some funding and getting some help from the school to implement this project.
To add on to that, if this concept is proposed alongside a research project of sorts, that opens up other kind of funding as well, since other institutions and organizations would be likely interested to know, does this kind of campus level improvement make a noticeable difference? And that's just another source of funding that's possible.
Yeah.
To add to that, you mentioned how this could be a potential saver of money. So the thought just occurred to me, and I wish we included it in the presentation, that carbon credits are a thing. So maybe, I don't know like what the rates are, but if the entire campus started sequestering carbon, then they could sell that carbon credit to other companies that that are more harmful in their CO2 output. So that would be a way to raise money.
Yeah. So I mean, all of these things you're mentioning, it's investment, right? It's an infrastructure investment for the long-term payback. You think of solar, for instance, as a perfect example. You invest in solar up front, and then it eventually pays for itself, and then some. All right. Oh, so good. A couple of good questions. I think you'll dig.
Professor Lazar, just one second. Sure. I want to add to this. First of all, thank you for the presentation. It was magnificent. It was excellent. You used all the right tools to come up with a fantastic presentation. We appreciate that. You did a lot of good to all of us and yourselves. To answer your question, at least to add to the question about cost, since this is the prototype, one of many projects to come in, this is one out of 25, 26, or 24 grids. So we anticipate another 24 different sections to materialize. And when they are fully completed, they will provide a tremendous amount of cost savings to the school. One obvious cost is the water cost. There'll be no more sprinklers needed. We'll probably have virtually a ground surface that is permeable enough to move the water from the top and take it down, irrigate whatever needs to be irrigated or sprinkled, and at the same time, replenish the groundwater table. So there are many, many benefits, as you pointed out in the presentation, that will materialize from doing these projects. Obviously, the school has to participate in some of these costs to defray the cost of these projects, but we will find, and as you have already found, solutions that are very sustainable and solutions that can actually last for a long time. The solutions that you guys have picked are solutions that are in a battery of options that we have as sustainable professionals that will last for a long time. So whatever cost you put down right now in the project, it will pay off for years and years and years in the future. So that's my 2 cents on this. Yeah. Overall, I think it was an amazing presentation, and more to come.
Yeah, I think the point about water is so critical. I think especially as we're going to see, we know the drought is not going anywhere. And especially where we are at CSUN, and food production is going to be, we're going to need water to help buttress our local food system, right, and the food production. So all these things can definitely contribute. All right, so I got some other good questions here. So about someone asked about the permeable asphalt or cement, the permeable surfaces. Would it be where, the student asks, would it be where cars park or drive? If so, how would you look to deal with the runoff, the chemical, oil, the car runoff, essentially, the waste? Is there something that's, and maybe this might be a question for Professor Lazarus, how do you deal with those kinds of, when you have permeable surfaces with cars and that kind of thing?
That's particularly true for areas that are holding parked cars, correct?
Yeah.
Leaking cars, older cars are leak gas and petrol, whatever. Obviously, in those areas that we have stagnated parking, we'll have a permeable surface, but not very permeable to allow all the contamination to go down the water table.
Right.
At the same time, we need to look at the water table and see how deep it is. And depending on how we park the cars, we can ascertain on how we put the foundations, the base and the sub-base for the pavement. Obviously, if the groundwater is deeper, I think based on what we've seen, it's about 20 to 40 feet deep. Correct me if I'm wrong, Tyler, Sean, Saul, and Anthony. So we can have those 40 feet of soil acting as a filter to naturally hold off and decipher, pick up the bad ingredients, and at the end, it will allow it will filter out the water to go through the groundwater table. But we will take a look and make sure that concentrated areas that have a lot of stagnated oil and contaminants like this will not be penetrating the ground surfaces. So accordingly, we'll build impermeable surfaces to alleviate that potential contamination.
Yeah, good. So another question about the location. So a couple people asked about, well, how do you calculate the location? Maybe you could talk about the grid. And so someone asked, was it GIS or DEM? I don't know what, I'm not sure what that stands for. DEM's utilized. But go ahead, Sean.
Oh, sorry, for Side A, we were still on campus, and the ASE, Associated American Society of Civil Engineering, CSUN chapter, was practicing for the PSWC, which is a conference. So I had asked the surveying team to collaborate. They needed practice, and I needed their assistance. So Site A was actually surveyed. Just the Site A itself, but all the grids, since when we were doing that, we were already home, that all the areas were calculated through Google Earth, the measuring tool on Google Earth.
Yeah. Excellent. It seems to me like you were all very resourceful in thinking of figuring out soil profiles and slope, and I mean a lot of that stuff. Fortunately, facilities has gathered that information, our tree atlas, all this kind of stuff. But I was just curious how you, I guess coming back to process again, just how you all, well, this is more of like a reflection. Where you are today, is this what you, when we first set out in this project 14 weeks ago, 13 weeks ago, is this where you, I mean, any surprises, or is this where you thought you were going to end up? Or obviously not virtually, where we didn't think we were going to have a COVID-19, but besides that, anyone want to speak to that?
I can start off. For us, it was an interesting transition, obviously, but it didn't derail us too far. If anything, it more or less cut us short, because originally in our first conversations and discussions at the Institute were about even potentially setting up an actual prototype, like physically making something. But unfortunately, all the distancing and just risk, that was shelved for this semester for our time. So we had to cut it off at making this kind of presentation where more people got to hear about it and hopefully inspire future students and future groups to continue the work once it can be done, with now a nice foundation to work off of.
Yeah, great.
Yeah, I think the team was resilient enough and flexible to pick up on areas that we couldn't do outside, and they were able to do it and complete this virtually. Obviously, you had some obstacles in finding information from labs and couldn't use the labs to do anything, but that's fine. You were resourceful enough to find out things, you know, using our service and using information that we have online. So kudos to everyone. I mean, you pulled out a very good presentation project and something that a lot of future students will look at and say, wow, I'd like to continue in this one. And that's what we hope for. We hope that we do the same thing for the other 23 sites and much more. So again, kudos to everyone.
To add on to the future groups, when we started on like day one, I guess we had the expectation that we would have like proposals for several sites. But like just due to like natural inefficiencies of like never doing this before, we had to like scale it back. But part of our deliverables for this class is that we have to make a report about, and it'll include like what we would do differently and our methods and all that. So we'll propose like recommendations on how to streamline what we did so that future groups
Great.
produce something that's hopefully better.
That's great. Yeah, we'll put that, and we'll have that posted on our website. There'll be a link to your project and this lecture as well. So I guess this might be good because we got about 20 minutes. This might be, if you guys, Anthony, if you wanted to pull up that, so maybe you could pull us up and then you also tell us what because this wasn't part of our initial, this is something that you all were inspired to do, this little presentation, a supplemental presentation. You could tell us maybe your rationale behind that and then just go launch into it.
Let's see. All right. Yeah, so this presentation was definitely more of a recent development because and especially so, like, we have to give him a lot of the credit for drafting this and getting it ready. But we'll get started on it. So do you want to kick it off? All right.
So my teammates here, Tyler and Anthony and Sean, they had the great idea of thinking of how can we provide people more value with our presentation since everybody's at home, and we thought this was a perfect opportunity to give you some quick tips on improving your own home landscape. So if you go to the next slide, please. So just a quick overview. You can beautify your own home with simple techniques. Sustainable gardening goes a lot beyond just using organic methods for growing food. You could save a lot of water and energy and save and have a lot of waste reduction. And there are a lot of just ways, many practices we can implement to be more sustainable with our home gardens. And in this short presentation, we're going to go over some brief problems we can solve. So by looking into watering, you could determine how much water your plants actually need. And by looking into it, you won't overwater and you won't waste water. You can also determine your landscape needs. Landscapes are designed to thrive in local temperatures, so finding native plants will only improve your garden. Practicing organic gardening. This is really important because the fewer chemicals you use in your garden, it's just a lot more ecologically sound and more cost effective. Another problem we can solve is just having zero waste. So examples of this can be if you compost at home or if you use mulch. Next slide, please. Introducing xeriscaping. So this is kind of, well, at least I thought like the idea of xeriscaping kind of puts all these things together. Xeriscaping is a systematic method of promoting water conservation in landscaped areas. And although a lot of the times xeriscaping is talked about in arid regions, just the principles of xeriscaping can be used in any region to help water conservation. Rethinking your garden, planning and design. Using a plan and having a design, it provides direction and guidance. Your water and mapping out your water and energy conservation strategies will help you, and this will be dependent upon your regional climate. Selecting and zoning plants appropriately. This bases your plant selections and locations on the location that you are in. Grouping plants with similar water needs is always good too. And just a quick tip, improving the water soil. This enables soil to better absorb water and encourage deeper roots. Maintaining landscape. This is important because it provides you with practices such as irrigating efficiently. This helps the plants and it's just a lot more efficient in its totality. Using mulches, this keeps plants cool, it minimizes evaporation and prevents soil from crusting, and it reduces weed growth. Another quick tip is, sorry, can you go back to that one? It's just by weeding, pruning, and fertilizing, this can help you maintain the landscape. And composting. We've all heard of composting. It's nature's way of recycling. It's just the natural decomposition of organic materials. And here on this slide, it's just a couple simple steps you can take to begin your composting journey. Next slide, please. And here are just some links that will help further guide your garden improvement. There's a link to composting, finding plants that are native to your area, mulching, and figuring out how to water your plants.
We'll put this on the website again.
Yeah. Thank you and happy gardening.
All right. So, so any last thoughts from the group of, you know, what would be your hope? I mean, you guys outline next steps, but what would you want to be adopted first? Any aspect of your project, if you had your choice of you know, one of the areas, or just kind of a education component or the infrastructure component, or?
I personally would be really happy to see the the permeable surface replacement, because I feel like I haven't really seen that much in any areas that I've been in. So it'd be really awesome to see that implemented.
Yeah.
I agree with Anthony, and we'd even considered for that as a solution for the permeable pavement to do those celebrick things.
Oh, right.
You know, where you sell a brick and you put your family name or whatever.
Yeah.
As part of the funding, right?
That's right, part of the funding. Yeah, I think what I like about this project is it does have this, it's about the campus, but it really is has its you know, it's looking outwards too. It's like a template for other CSUs, but even more locally, just for the valley, for Northridge and the valley, and just thinking of these spaces as carbon sequesters and water retention.
Yeah, I mean, really
devices.
looking at it both ways. Hold on. On both ways, on top and below ground surface,
Exactly, right.
carbon sequestration,
Yeah.
and then water sequestration, right? I mean, it's a shame to see all this water run off and go into the street, go into a catch basin, which will eventually lead into a pipe and into the Santa Monica Bay. I mean, this is horrible stuff. So we want to capture all this stuff and put it into the ground and let it thrive. Okay, so this is just one out of so many projects in the future, and that's why we gave it this. You gave it this beautiful name, Lung Project, because it will continue. One will connect with the other, and there's so many sites to connect, and it's like a living lung. It will all connect and breathe. So we can have a CSUN campus that is communicating. Every part that's below and underground and above ground will be communicating with each other. So that's why I think you did a magnificent job in giving the idea that this is what we're going to do in the future, to connect every one of those pieces.
Yeah. So, with that, any last thoughts from the audience or questions? Well, 401 group. Oh, someone says it was called the lung, L-U-N-G, like breathing. Think of the campus as a breathing ecosystem, right? As a interconnected. Yeah. So, good question. You know, as again, interconnected above and below, but also across. And I think this is what's so exciting. And all the students here think of it as are intellectually interconnected too, with these different backgrounds, but yet they were able to come together and create this really inspiring vision for the future. So I want to thank you all. Thank you guys for working with us and for inspiring me and inspiring the Institute. And we're looking forward to promoting this and hopefully implementing this in the years to come. So, so congratulations to you all.
Thank you.
Thank you. Congrats.
Okay. And for everybody else, thank you for coming, and keep checking out our website. We're going to be doing more of these projects, more of these presentations in the coming month. So have a great day, everybody.
Bye now. Good luck.
Bye.